Hello everyone, this is Priyanshu Choubey, Assistant Professor of Suresh Gandhi University. Today we will talk about minerals definition, and mm, mm, some minerals terminology. We will discuss about here. And last video we already talked about basic information about minerals and about the crystal and also a crystallography. Today we will discuss about silicates. What is the silicates mineral? So let's see. Uh, what is the silicates? Classification of silicates minerals. The a summary of structure of different layer silicates. Uh, Silicates minerals are characterized by the presence of silicon oxygen bond. In addition to silicon and oxygen, the other ions present in these minerals are aluminium, iron, ferrous and ferric, magnesium and manganese, lithium, titanium. Silicates are classified in a different groups according to the number of silicon bond oxygen linkage present in them. It is equivalent to the number of corners or silicon tetrahedron is sharing its oxygen with the adjacent tetrahedron. The group like nilosilicates, orthosilicates, or silicates. So there is a number, there is no silicates linkage. There is a number of the silicon oxygen and silicon linkage. No corner of a silicon tetrahedron is sharing oxygen with any other tetrahedron. The tetrahedron are linkage together through a magnesium or potassium ions, which remain in octahedral coordination. And the name of the group mineral in this class is olivine, and the general formula of magnesium ferrous oxide, silicon oxide. The name of the and member or uh, first type, magnesium Mg2 silicon oxide, and the phyllite. So, classification of silicates minerals are silicates class are a unit composition arrangement of silicon. Like minerals ideal formula, silicates class and unit composition of arrangement of silicon oxide. Nesosilicates Nasosilicates, minerals name olivine, phosphide, and phyllite, and zircon, spren, and topaz, and granite. Ideal formula, olivine formula, in bracket Mg Fe2 as silicon oxide, forsyth Mg2 silicon oxide, and falside Fe silicon oxide, Zircon Jadar silicon oxide, Stran Ke titanium oxide, silicon oxide, topaz, aluminum oxide, in bracket iron oxide, sorosilicates formula silicon. It means silicon. Um, Silicon is two and oxygen elements or seven. Epidote, 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 calcium, aluminum, iron, aluminum oxide, silicon oxide, and OH. Silicate classes and unit composition arrangement of silicon oxide, like crest. Silicate, mineral gray, one tourmaline, ideal formula Be3L2 Si6O18. Silicates, single chain, pyrohexane, aggregate, anthracite, and dioxide, pyrohexanite. As silicates, double chain, amphiphos, on horn blend, and chermolite. Phyllosilicates, mica, moscovita, biotita, chloride, clay mineral selected talc, kaolinite, vermiculate. Silicate class unit composition arrangement of silicon. So, tectosilicates, feldspar, orthoclase, albite, anthracite, silicon groups, quartz, tridimites, and crystal, geodesic, anacline. In this class is olivine and the general formula of magnesium, iron, and silicon, the names of and the member of for stripe and phyllite. Inosilicates or chain silicates. There are two types: single chain pyrohexane group of minerals and double chain amphiboles groups minerals. Pyrohexane single chain. In this mineral, two corner of silicates tetrahedron are shared by the adjacent tetrahedral. So the number of silicon oxygen silicon linkage is 2 per silicon oxide with formula. Uh, the negative charge of this change are balanced by a magnesium and iron in six-fold coordination. Residing the side between the two silica chains, thus binding the two chains together. This mineral have a chemical formula XY silicon oxide, where Y is a smaller cation. Mineral have a chemical formula XY silicon oxide, where Y is a smaller cation. Example magnesium and iron lithium. But X may be larger cation calcium and sodium. The and sum of charge X and Y is a 4 plus. Example pyrohexane minerals are the installite hyperthan dioxides and agoit. In agoit agoit substitution of magnesium and iron in octahedral site and silicon is a tetrahedral site in done by aluminium. Amphiboles double chain. This minerals alternated two corners and three corners of silicon tetrahedrons are shared by adjacent tetrahedral. So the number of silicon oxygen silicon linkage the 5 per 2 silicons. With formula silicon 4O11 inverse 6 minus 6 and is where such tetrahedral 1 and 3 share two corners. Where the tetrahedral 2 and 4 share three corners with the adjacent tetrahedron, the negative charge of these chains are balanced by the magnesium in six coordinations and the larger calcium. In eight coordinations residing the sites between the two silica chains, thus binding the two chains together. The amphibole has a chemical formula is the X uh, 2Y5 uh, siliconate, oxygen 22, and hydroxide 2, where large cations such as the cations occupy a bigger side and smaller cations such as magnesium occupy a similar side. So, example of the amphiboles minerals are thermolite and actinolite and hornblende. Uh, Polysilicate, phyllosilicate. These silicates are three vessel oxygen are shared with the three adjacent tetrahedrals, thus having a three silicon oxygen silicon bonds per tetrahedron. The fourth apical oxygen is shared with and the octahedral cations such as the aluminium and magnesium, thus producing a two-dimensional seed structure of formula having oxygen and silicon or oxygen silicon network in uh, AB plan parallel to the horizontal. Important minerals in this group are mica, chlorite, primary minerals, and elite and vermiculites, padogenic chloride, and Sematites, colonite, and secondary minerals are these minerals are most common constituents of a soil and will be discussed in details in a soil clay and clay minerals. So tectose silicates or network silicates. These silicates, all the oxygen of a tetrahedron are shared with the four adjacent tetrahedral, thus having a four silicates or silicates, oxygen silicates bond per tetrahedron. A common example of tectosilicates in soil are silica and feldspar. Silica mostly occur in sand and silt friction, but is also found in a clay friction. In nature, silica occurs as distinct polymorphs, polymorphs like quartz, crystoblyte, terdimite, uh, cosites, stereovoids, and laterite silica glass also. And opal where polymorphs are the different structure form of the chemical compounds. Out of this polymorphous quartz is the most abundant in soil. While disordered cristobalite opal is also commonly found in soil. Terdimite is rare in soil, usually associated with the cellulose volcanic rock. Opal is hydrid amorphous silica that compress the bulk to diatomeous rock of biogenic origin of silica of inorganic origin. Although all silica polymorphs exhibit framework tetrahedral structure, the pattern of tetrahedral linkage for each mineral is different. Feldspar also have a structure three-dimensional framework of linkage of silicon oxide and aluminum oxide also. Tetrahedral with a sufficient opening in the framework of to accommodate potassium, nitrogen, calcium, and beryllium to maintain neutrality. One zigzag chain is formed by the formed by the superimposing four-membered rings to a tetrahedron that share some of their vertices to from new four-membered ring. The remaining vertical form a cross link between chain. These rings are linked together to a form honeycomb type arrangement. Can I actually feldspar Anhydrous aluminum silicates of the potassium and sodium and calcium named as the ortho orthoclase orthoclase, macroline, and anthroclase, and pegoclase, albite, and anorthite. Orthoclase and microclase are the polymers having the same chemical composition but different symmetry. Orthoclase is a monoclinic, whereas a monoclinic is a triclinic potassium feldspar occurs commonly in silt and silt and sand frictions of the soil. These are also abundant in the clay size frictions soil which have undergone little weathering because of distribution in fine silt and clay size friction. This serve as an important source of potassium in soil, but are comparatively less important than a mica. The Palgo clays for series consisting of the solid solution of albite and anthracite. Geolite also the tetrahedral link by the sharing the all their the verticals to form a framework structure. They may be linked into a wide variety of ways by making a 6, 8, or 12 membered ring, which are the joined together in the less compact way than the feldspar. Soil clay and clay minerals. Soil and clay minerals. Any particle of less than 2 mm, uh, 2 micron, 0.002 mm size is defined as a clay. A crystalline clay having a long range order in all the three dimensional is called a clay mineral. Repeat again. A crystalline clay having a long range order in all the three dimensional is called a clay minerals. Common clay minerals belong to the group of layer silicates. Group of layer silicates or aluminosilicates called phyllosilicates or oxides, hydroxides, of iron, aluminum, and magnesium and silicon. Beside these three are non-crystalline clays are such as amorphous oxide and hydroxide and aluminium silicate. Hello everyone, this is Priyanshu Choubey, Assistant Professor of Suresh Gandhi University. Today we will talk about minerals, silicates minerals, which is already the last video we already talked about it, discussed about it. Let's continue. Soil clay and clay minerals, already we talked about it. Any particles of less than 0.002 mm size is defined as a clay. A crystalline clay having a long range order in all the three dimensions is called a clay minerals. Common clay minerals belong to the group of layer silicates or aluminosilicates called phyllosilicates and oxide and hydroxides of iron, aluminum, and and silicon. Beside these are there are non-crystalline clay such as amorphous oxide, hydroxides, and aluminum silicates. So, crystalline aluminosilicates structure principle. Uh, First one. So, layered silicates are most conventionally described as the combination of tetrahedral sheet formed by linking tetrahedral group like silicon oxide or octahedral silicates formed by linking octahedral group aluminum oxide in three-dimensional. I repeat again. Structure principle layer silicates are most conventionally described as a combination of tetrahedral sheet formed by linking tetrahedral group silicon oxide and octahedral sheets formed by linking octahedral groups aluminum oxide in three-dimensional. Clay minerals are combination of tetrahedral sheets and octahedral sheet in a 1:1 and 2:1. Tetrahedral seed is a combination of tetrahedral silicon groups and octahedral sheet is combination of octahedral aluminum oxide groups. A sheet is combination of plane of atoms and layer is combination of sheet. A sheet is combination of plane of atoms and a layer is combination of sheet is 1:1 or 2:1. In addition, layers may be separated from one another by a various interlayer materials such as cation, hydride cations, organic molecules, and hydroxide octahedral groups. In tetrahedral sheet, each of three silicon oxide coordination groups share oxygen atoms with three neighboring oxygen silicon oxide groups. One oxygen shared with one neighbor only, which is called a corner sharing. This tetrahedral form a ring hexagonal activity connecting six silicon and six oxygen. Each ring is joined to the adjacent ring through shear oxygen atoms. The oxygen atoms are approximately coplanar and are called basal oxygen atoms. This fourth oxygen from the H of silicon oxide is the oriented normal to the basal plane. These are called apical oxygen atoms, which are also coplanar. The octahedral sheet is built up of aluminum oxide and magnesium oxide octahedral groups, which with each groups sharing a pair of oxygen with one neighboring group. This is called edges sharing, where of aluminum or magnesium cation share two oxygen atoms with the aluminum or magnesium cation in the adjacent octahedron. These are two ways in which this sharing takes place if all the octahedral sites cation, contain cation equivalent magnesium. Each share two oxygen atoms with each of six uh, neighboring cation. Magnesium. The sheet so formed is called as a trio octahedral sheet. On the other hand, if any two-third of the site contain cation aluminum and each aluminum share two oxygen with only a three aluminum. Three aluminum neighbors. The sheet is called as the dioctahedral sheets. Linking of tetrahedral sheet and octahedral sheet to form a layer. Linking of tetrahedral sheet or octahedral sheet is form a layer. Linking of tetrahedral sheet and octahedral sheet take place through the apical oxygen of the tetrahedral sheet. This plane becomes a common to both tetrahedral as well as octahedral sheet, and the connecting oxygen atoms is shared by both tetrahedral aluminum silicon or aluminum and octahedral aluminum or magnesium. The rest of the anion groups in this plane remain as hydride and belong only to octahedral sheet. Tetrahedral sheet is longer, b-dimensional than the octahedral sheet. During a linking of two sheets, the tetrahedral sheet must contract. This is achieved by two adjacent tetrahedral rotating is opposite direction. As a consequence, the hexagonal activity on the tetrahedral sheet change its shape to diagonal cavity in real structure. It has a very important consequence of potassium bonding in the interlayer of mica. Stacking of layers, a number of layers thus formed as stuck together vertically, one after another from clay particles. This space between two ad, adjust layer is called interlayer space. The bond between the two stacking layers may be a different step, like Wonder Wall walls and pores in case of pyrophyllite and talc. Electrostatic attraction between a negative charge in the layer and interlayer cation in the interlayer, as in case of other 2:1 clay minerals. H bonding between hydrogen bonding between a OH group of one layer of oxygen group of other layer in the case of colloidal minerals. Sometimes a solid seed may be present between solid sheet may be present between the two layers and attached with the two layers by electrostatic attraction between a negative charge in the layer and positive charge in the interlayer sheet, as in the case of electrochloride. Development of a negative charge in the layer depending on the types of minerals. Portion of aqua driven silicon is tetrahedral seed replaced by a trivalent aluminum, or a portion of trivalent aluminum is replaced by a divalent magnesium ions in the octahedral seed. This is called isomorphous substitution. As a result of this, the negative charge develop in the layer. The amount of charge developed will be equal to the amount of substitution. For example, if one silicon ion is substituted by one aluminum ion in the formula weight of the mineral, It is result in the development of one equivalent charge of per formula weight. This layer charge is a very important property which determines its properties and classification status. So, principal structure group. There are five main structure group of layer silicates mineral which occur in soil as the clay minerals. First one, kaolin separating group with uncharged 1 ratio 1 tetrahedral ratio octahedral layers. Pyrophyllite talc group with uncharged 2 ratio 1 tetrahedral ratio octahedral ratio tetrahedral layers. Mica group with a charged 2 ratio 1 layers. Interlayer anhydride potassium. Uh, Semicistite and vermiculites group with charged 2 ratio 1 layers and interlayer cation whose hydrons state varies with the humidity. Chloride groups with a charged 2 ratio 1 layers and a positively charged hyd- hydroxide interlayer beside a layer silicates. Other minerals such as feldspar and silica may also occur in a clay section. Dioctahedral minerals of kaolinite groups. In each, the three minerals connected in this group, kaolinite and dicite and necrite. One tetrahedral sheet is linked that its apical oxygen to an octahedral sheet, connecting two-thirds of this octahedral sheet occupied by a trivalent ions, aluminum ions. The linking oxygen belong to both tetrahedral and octahedral sheet. Other atoms in this uh, plane are hydroxide groups which belong to the octahedral sheet. These hydroxide groups are called inner or hydroxide groups and located vertical above the hexagonal cavity. Those hydroxide groups are placed at the outer surface of octahedral sheet as called the outer hydroxide. Uh, the unit cell of colonite in the Z, Y, or CB plane unit cell, the smallest three-dimensional section of minerals, which are repeats in all the three-dimensional as along the z-axis, c-dimensional of the cell started with the plane of order OH group of octahedral sheet having a six OH groups followed by a octahedral aluminum plane. Oxygen, 4 oxygen plus 2 OH plane, a tetrahedral 4 silicon planes, and outer 6 oxygen plane, which makes a hydrogen bond with the hydrogen hydroxide planes of octahedral sheet of the next chloride layer unit. This distance from the OH plane of one unit to the corresponding OH plane is the repeated distance between distance along the C-axis and is called the C-axis spacing of the mineral in the planes of outer oxygen more than six oxygen or here. The oxygen with a cut bond share only half with the silicon in the unit cell. The other half is shared with the silicon of the other unit cell. Three are six such half was shared oxygen and three full shared oxygen here. In this structure, total six oxygen. So if we calculate the total positive charge of the cations and total negative charge of the anions, it is in the unit cell like cation 4 aluminum is equal plus 4 into 3 is equal to 12 positively charged, and anion 6OH is equal to minus 1 and into minus 6, so minus 6 negatively charged, and 4 aluminum is equal to 4 plus 4 into 4 is equal to plus 16 plus 16. An iron 4 oxygen plus 2 OH is equal to minus 2 into 4 minus 1 into 2 is equal to minus 10 is or 6 O is equal to minus 2 into 6 is equal to minus 12. So total 26 cations positively and total 28 negatively. So the net charge is 0, and the structure is neutral, and the unit cell formula is silicon, aluminum, oxygen, confirming to the phyllosilicates formula of silicon pentoxide for the 1:1 trioctahedral. Uh, Structuring the ideal chemical composition is magnesium silicon hydroxide. Strutting contains only divalent cations in the octahedral sheets. So here completed at a 1:1 the di-octahedral minerals of the kaolinite groups. Thank you.